All right, guys. Today and tomorrow, we are going to work through this very last section. So the notes I gave you today are for today and tomorrow. We'll do part of them today, do the other part of them tomorrow. This is the last set of notes you get from me. I know, right? I can't believe we're almost done with our time together. It's crazy. So today and tomorrow we'll get through the notes. Thursday we'll do a little activity to practice the solving, and then Friday will just be a little quiz over just the solving part. Okay? And then that's it. Friday's my last day with you guys. I know, right? It's crazy. As far as your quiz you took yesterday, I honestly have not even looked at them, so I will work on getting those hopefully graded tonight. All right, but for today, we are solving. So first way of solving is when we have exponential equations that have the same base number. So it's called a one-to-one property. So before I even get into this one, if I would ask you guys, if I had 5 squared equals 5 to something, what does the x have to be? It has to be squared, right? So it's going to make them the same thing. So same idea down here. If I have 5 to the 2x plus 1 equals 5 to the x plus 4, what do we know about those two exponents? They have to be equal to each other. Because I want 5 squared to be 5 squared. I need them to be the same. So I need those exponents to be equal. So I can set those equal, and then I can solve for x that way. Okay, so if the base numbers are the same, you just take their exponents and set them equal to each other. So for this one, are my base numbers the same? But can I rewrite one of them so that they are the same? Yeah, I can rewrite 9 as what? Good, so I can rewrite 9 as 3 squared. By rewriting it as 3 squared, I now have the bases are the same. They're both 3's. So what do I know then about its exponents? They have to be the same. They have to be equal to each other. So then I can just set 2 equal to x plus 1 so that I can solve. So in this case, x equals 1. And again, we can always check, right? This is a pretty easy check. You can probably do this one mentally. If I plug that back into the original, 1 plus 1 is 2, and then 3 squared is 9. So I know it works. Okay, so the great thing about these is you can always go back to the original problem, plug in your answers, and make sure they do work. Andrea. Yes, it was me setting this equal to that. Since the base numbers are the same, that means those need to be same if we're going to say that they're equal to each other. Other questions? Okay. All right, so if I have 16 equals 2 to the x plus 2. Right now the bases are not the same. One's a 16 and one's a 2. So can I change one of them? Yes. Good. Good. 2 to the 4th power is 16. Right, so I can rewrite that. This one's still 2 to the x plus 2. Since these base numbers are the same, and I'm setting these equal to each other, that means their exponents, they should be equal. So 4 equals x plus 2. So x equals 2. Again, this is one of those sections that I get angry when people get them wrong, because you can check this. Plug it right back in the beginning. If that's 2, 2 plus 2 is 4. 2 to the 4th is 16. So I know that it worked. All right, what about the next one? 5 to the 4x equals 25 to the x minus 3. Good. So I can rewrite the 25. That is 5 squared. What do I do with the x plus 3? Or x minus 3? Good. It's a parenthesis. And this is still 5 to the 4x. Okay, so the big thing is you want to try to rewrite your bases so that they are the same. And then once they are the same, I know their exponents. Right? These are the same. So then this must equal that. So 4x must equal 2 times x minus 3. And then we just solve from there. So we'll distribute. we get 2x minus 6. Subtract the 2x over. So 2x equals negative 6. So then x equals negative 3. We'll get there. Oh, fractions. Yay! Everybody's so excited. Can I rewrite those bases so they're the same? Well, how do we move a number from the top to the bottom or from the bottom to the top? Negative exponents, right? Okay. So right now the number's in the bottom. So to make the 8 go to the bottom, I know I need a negative exponent. Can I turn 8 into a base of 2? 2 to the what? It'd be 2 to the negative 3 is what I'd be looking for. So let's kind of talk about what we just did here. Because what's happening, in order to move this 2 to the bottom, I needed a negative exponent. It's going to move it to the bottom. And then it's a 3 down here. Oops. So am I able to think of that as this whole thing to the third? Can I move it out here? Is that okay? Yeah, same idea. Right, that negative exponent, just push that to the bottom. So should I still leave it negative? Should I leave it positive? I know the negative's what I need to push it to the bottom. So if you're not sure, right now they're the same, right? The question we're asking is, should that be a 3 or should it be a negative 3? Go back to the original problem. If I plug a 3 in here, does it give me that, or does it need to be a negative 3 to give me an 8? It needs to be a negative 3. So this is still negative. Okay. So we can kind of forget the center line here. Because what's happening is that negative, forget this part of the problem for a minute. If I gave you this and I asked you to simplify it, the first thing you would do is flip that 2 to the top and make that positive, and then 2 to the third is 8. Bless you. Okay, so then we know that x equals negative 3. Is there another way I could have done this? Like maybe, I don't know. Bless you. Yes, I know what you mean. Yes, I know exactly what you're talking about. She's thinking of, I can move this back to the top, right, by making this one negative, and then I can turn the 2 into an 8 by cubing it to the, so it'd be negative 3x would be your exponent. What's the exponent on this one? Oh wait, this would be negative 1/3, sorry. And that would be, the exponent on this is a 1. So then I can solve it that way. I think that way gets a little more confusing. Now, if right now your head is going, oh my God, I'm never going to remember which way these things go. I don't know what I'm doing with this. That's okay. I'm going to show you another one real quick we'll go through, and then I'm going to show you something that allows you to solve these without rewriting the bases as the same. So if the fractions confuse you, don't panic. Okay, if I come over to this one, can I change the 81 so that it is on the bottom and it has a 1/3 for the base? How do I rewrite that? Because I want this to be 1/3 to something. I want the bases the same. Good. It'd be, is it just the 4th? It'd be negative 4. Because again, that negative is going to make this 3 come up, and then 3 to the 4th is 81. So in this case, then I know x equals negative 4. So the fractions get a little confusing sometimes. I know some of us just don't like the fractions, the negative exponents, that whole thing. So Is there a way that we can rewrite those and do them another way without writing the same base? And the answer is yes. And we're going to get to that today. All right, so when the bases are not the same, you can solve the equation by taking the logarithm of each side. So if I look at the problem, 5 to the x equals 12. I can't rewrite 5 or 12 so the base is the same, right? They're just not, I can't do that. So what we can do is we can take the log of both sides. As long as I do it to one side of the equation and the other, it's balanced, and that's okay. All right, so take a look what happens here, guys. If we're just literally sticking the word log on both sides. It's balanced because I did on both. Then my x is what I'm trying to solve for. It's an exponent, so our properties say that it comes out in front, right? Exponents we throw out in the front. And then to solve for x, how do you get x by itself? Divide by the log of 5 on both sides. So that cancels, and I have x by itself. And then I'm going to type this in my calculator, and I'm just going to round it to whatever it tells me to round it to. Because remember, our whole point in this is to solve for x. Logarithms help us when the x that we're solving for is an exponent, because that property allows us to pull that out in front. So 15 to the 3x equals 285. Now, I'm going to tell you guys right now, the first part that I covered with you about rewriting them to the same base, some people like that and they will do that. Others will be like, let that go right out of my head, and they'll just do them like this. And it honestly doesn't matter. So since I cannot rewrite these as the same base, all we have to do is write the word log in front of both of them. I want to be kind of lazy here. Just kind of shove that in between there. And then my properties allow me to take this exponent of 3x and put it out in the front. So the 3x comes out in front, and then I have log of 15 equals log of 285. Questions so far? Log of both sides, keep it balanced. Exponents get thrown out in the front. And now, can I get the x part by itself? Now, keep in mind, guys, what happens when you type the word log in your calculator? What automatically happens? It opens that parenthesis, right? Which means this 15, that's connected. It's open in the parenthesis, and you're going to close it off afterwards, right? That's connected. I can't take the 15 away from that log, okay? But what I can do is divide both sides by the log of 15. So they cancel here. Now 3x equals, grab your calculator. We're going to do the log of 285, close parenthesis, divided by the log of 15. Okay, so 2 point, a whole lot of digits, right? So at this point, don't clear your calculator. I got 2 point, a whole bunch of digits. I don't want to round yet because that will alter my answer. X is not by itself yet. I need to divide by 3. So in my calculator, while I still have all those digits, I'm going to hit divide by 3. Now I'll go ahead and round my answer. Let's go ahead and take it to, let's see, homework tonight wants the 10,000th. How many digits is the 10,000th? Think of the number 10,000. How many zeros are in it? There are 4. So it's 4 digits. All right. So it would be 0.695. Would round to an 8. Now, usually at this point, somebody's like, I don't know if I did that right. I'm going to check my answer. Right? So if I go back to the original problem to check this. All right, so if I do 15 exponents, if I just do 3 times this answer I wrote down here, is it going to be right? Why not? This is rounded. Okay, so can I check it in my calculator and use all the digits? You can. Guys, try this for me right now. Type in 15, hit your exponent, do 3 times, arrow up until the full answer is highlighted, and hit enter. It'll drop that into your equation where you want it. and then hit enter again, I got 285 point, a bunch of zeros, and then a 1 at the end. Is it still okay? Yeah, why did it give me all of that and the 1 at the end? Did anybody get 284 and then a bunch of 9s? Exactly 285? Well, that's funny, and I didn't. Did you get all those zeros and then a 1 at the end? What happens is your calculator, while it's very smart, it has its limits as well. Okay, so this huge digits that was all in my calculator, it's holding as much of that as it can, but sometimes things get a little rounded off somewhere along the way. So some of you got a beautiful 285. I have 285 and then a bunch of zeros and then a 1. Sometimes I'll see 284 and then a bunch of 9s afterwards. But in essence, it's the same thing. Okay, so don't panic when you get that just slightly off a little bit. You got something totally wrong? All right, so the next one, 5 to the 2x equals 130. I cannot rewrite 5 and 130 to be the same base. Or even if you could, this method still works. Okay, we're going to take the log of both sides. Now, every year I have some students who only do log on one side, and that's not going to work, right? We have to keep them balanced. We got to do the same thing to both sides. All right, and then my log properties allow me to take this exponent and move it out in the front. Okay, so take your exponent, throw that number out in the front. Then what do I do? I'm trying to solve for x. Good. I'm going to divide by the log of 5. Keeping in mind, whatever that number is with log right after it, it's attached to that. I cannot separate that out. So we're going to do the log of 130, close parenthesis, divided by the log of 5. So we're at 2x equals, when I divide those, I get like 3 point something. Okay, but x isn't by itself yet. So then I'm going to divide by 2. Divide by 2. And we get 1.5122, rounding to the nearest 10,000th. Okay, again, if I think about checking my answer, going back to the beginning, it would be 5 exponent 2 times, go back up and snag that big answer you got. I have 130 point, a bunch of zeros, and this time I got a 2 at the end. You did too? Did you get a nice pretty answer again? So funny. They're all so very different. Scientific calculus. It's weird. Some like his one came out beautiful answer. But yours is coming out with the extra stuff. How many of yours come out absolutely beautiful, perfect answers? Just a couple. Okay. All right. 6 to the x plus 10 equals 47. I got more stuff going on than the last one. What are you going to have to do? Good. Let's subtract the 10 first. I'm trying to isolate that the x part as much as we can. So 6 to the x equals 37. Then what? Log. Guys, anytime your x is an exponent, the variable you're solving for, you know a log's coming in somewhere. Okay, so isolate it as much as you can. Then we will take the log of both sides. That allows us to pull the exponent out in front. So x log of 6 equals log of 37. Then what? I just divide 37 by 6. It's not there's 37 and 6. It's the log of 37 will be divided by the log of 6. Remember, that is very different than just 37 and 6. So log of 37, close parenthesis, divided by the log of 6. Should I write down my actual answer this time? Yes, because the x is by itself. Yeah. So it's 2.015, bless you, 3. So again, checking your answer, 6 exponent. Go ahead and snag your last exponent. Add 10. I got 47. I got a little 2 at the end, but you know, close enough. All right, questions so far, guys? We doing all right? For the exponent, I just typed in 6, went up to the exponent, and then I just arrowed up into my calculator where all of this was. Because what happens if I just use my rounded off answer? 2.0153, then plus 10. I mean, it's close. It's 47.00055299. It's close, but it's not quite as good. And it's because it's rounded. Yeah. What? You got a big number? What'd you get? Did you, when you checked it, that's what you got, or when you solved it? But did you get this when you solved it? All right, what about the next one? 2 to the 3 minus x equals 565. Okay, so what's the first thing I'm going to do? I know the part I have to solve for is an exponent. Log should be the first thing that comes to your mind. Okay, and that's what logs are for. They're used to solve for exponents. So we will take the log of both sides. I literally write log on both sides. Couldn't be any easier. All right, why do I do this? What's it allow me to do then? Good. It allows me to take this exponent and move it out in front. Now, what do you notice I did that you may not have done? That's in parentheses, because that is one whole big piece. It's one big group. Okay, from here, we will divide by the log of 2. So the log of 565, close parenthesis, divided by the log of 2. You get 9 point something something. All right, what do I have to do next? I have to subtract 3. So minus 3, I'm just going to hold it in my calculator, right? And it gives me 6 point something something. And then what? Divide by negative 1. So we end up with a negative 6.1421. You plug it back in and what? It doesn't work. What do you mean it doesn't work? So 2 to the 3 minus that. 564.9999999, just like you. 2, 3. Hold on a second. Oh, why do these just get weird? There's an E there. All right. What's E? A letter. It's a number. That's what I was looking for. It's a number. Right? E actually is a value of something. All right. So anytime you see E, what did we also talk about that had an E in it? The natural log. So let's talk for a minute. What is natural log? We use ln. We know it's a button on our calculator, but why do we use it? What is it? Natural log is what? Where does it come from? You said it had something to do with an e. Where does the e come in? It's log base e. Okay, natural log is log base e. I need to make sure we understand that so that what we're going to do here makes sense to you. All right, so what we're doing, anytime you have an e in your problem, you're going to use natural log, okay, because those go together. So if I go ahead and write the natural log on both sides, right, natural log, they're both the same kind of properties, right? I can do them on both sides. Now real quick, just pay attention up here, don't write this down yet. Natural log is log base e, and then I have e to the x minus 2. Now I only rewrote the 1 because I want you to see something. Yes. E to what power is e? Because my properties would have allowed me to take this and move it out in front. So the x minus 2 is actually out here. It's not in my thought process. E to what power is e? Is 1. So technically that's just a 1. Anything times 1 doesn't change, so I don't have to worry about that. So it allows me to, in other words, cancel out my e. It's gone. It's gone.
Pretty much the case.
Yeah. So log base e of e, e to what power, that's asking you e to what power equals e? 1. So in essence, this entire piece became a 1. So when I move those in front using my properties, this is really times 1, which, so what, it doesn't do anything. We'll do a couple more so you guys can see how that works. All right, finishing this one off, what's the only thing I have to do still? I have to add 2. Does that become the natural log of 14? No, it does not. So really all I'm doing is natural log of 12, close parentheses, add 2. So 4.4849. Just be careful. I think a lot of students are like, oh yeah, that's natural log of 14 then. No, you can't separate or do anything to that number that's attached to my logs. All right, so on the next problem, trying to isolate things, what do I need to move first? The 2. Let's go ahead and subtract the 2. So 4e to the 2x equals 14. Then what? Divide by 4. So e to the 2x equals 7 over 2. If you want to change that to 3.5, I'm okay. It doesn't really matter. All right, from there, I have an e. I know I need to do something with logs because my variable I'm solving for is as an exponent. Should I do log or should I do natural log? Natural log. Me doing the natural log of both sides is going to help me out. My properties allow the exponent to go out in the front. So I'll kind of do this in slightly different steps than I did here. So I have 2x natural log of e equals a natural log of 7 over 2. Now let's say you didn't even recognize the natural log of e is actually equal to, what's the natural log of e? It's 1. It's 1. It's 1 because again, that means log base e of e. E to what power is e? 1. So let's say you didn't recognize it. Could I still finish solving from there? Could I divide by the natural log of e? Could. But I'm going to be smart and recognize that this is equal to 1. And 2x times 1 is just 2x. So to solve for x, we will have to divide by 2. So in my calculator, we have the natural log automatically opens that parenthesis. So I can just do 7 divided by 2. I don't need to type it in as a fraction, not a big deal. Just then close your parenthesis afterwards, then hit divide by 2. So 0.626, and that would be a 4. Can I check these the same way I was checking the other ones? Yeah, absolutely. So I'm going to do that right now. So I have 4, and then times E. Remember, E is right above your ln button. It's going to open up that exponent for you right away. So 2 times, insert what you had going on there before. And then I have to do plus 2. Make sure you drop down out of the exponent, plus 2. Oh, look at that. It came out a beautiful 16 that time. 57. Something's wrong. Shouldn't be 57. Yeah. Really? You can wait. Brittany, did you find where you messed up then? All right, guys. The next question. 2 times e to the negative x equals 20. What do I do first? Divide by 2. Always trying to isolate as much as you can. So I have e to the negative x equals 10. I've isolated as much as I can to get to that x, my variable, but it's an exponent. When you're solving for an exponent, logarithm should come to mind. Do I do log or natural log? How do I know to use a natural log? There's an e. Okay, simple as that. So we will take the natural log of both sides. My properties allow me to take that exponent and throw it out in the front, so negative x. I have natural log of e equals a natural log of 10. What's a natural log of e? It's 1. Again, maybe make a note, something. That implies the log base e of e, which is asking you e to what power is e, which is just 1. Good. And if you recognize that, by all means, that is 1. So I don't really need that. So I have negative x equals the natural log of 10. Divide by negative 1. So we do the natural log of 10, close parenthesis, divide by negative 1. X equals a negative 2.302, and that would round to a 6. Check your answers. Go back to the beginning. So 2 times e to the negative answer you just had, and see what you get. And I got a beautiful, perfect 20. Yes, good question. So the question was, since there's already a negative right here, do I need to still put this negative in? Yes, you do. It's going to make that a positive, yeah. That's why we need both, because it's actually a positive that I need that to be in order for that to work. Yep, so anytime like you already have a negative in front, but your answer's negative that you're plugging in, you still want those signs. Because those double signs are going to change that answer. All right, let me give you guys a couple minutes. I want you to do the next one on your own. E to the 3x plus 5 equals 15. All right, guys, what's the first thing you did? Yeah, we'll subtract the 5. So we have e to the 3x equals 10. Did I isolate everything I could? Or do I need to move something else away? No, I moved everything. All right, so I know that I'm solving for x. It's an exponent, so then your brain should automatically think of logs, because logs are what solve for exponents. Regular log or natural log? How do you know it's natural log? Because there's an e. Yep, so we'll do the natural log of both sides. My properties allow me to move that out in the front, so 3x times the natural log of e equals the natural log of 10. And what do we know at that point? What's the natural log of e? This is 1. So really, I just have 3x equals the natural log of 10. So we have to divide by 3. So we'll do the natural log of 10, close parenthesis, divided by 3. And we get 0.7675, rounding my answer. To check all the way back to the beginning, we would do E, and that would be 3 times the answer I just got, plus 5. Make sure you are arrowing out of the exponent when you check, and it does come out a beautiful 15. Questions so far on anything? All right, let's go back to the beginning of these notes real quick. Just because. Let's come back to this one. So let's say you're somebody who doesn't like to remember more than one thing. You're like, oh yeah, that's me, right? Some of you are like, got it. I'm paying attention now. All right, so let's say I'm looking at this problem and my brain is going, I don't know. I don't want to do all that. I don't want to rewrite that. Whereas this is not hard, but let's say you didn't think about it. Can you still do this another way? Yeah, you absolutely can, right? So this one's a little more clear. Let's do this one. So this was my problem. Obviously, this is what we did originally, and we had an answer of 2. So let's say I forgot that I could do that, and I just went ahead and wrote the log on both sides. Okay, and that would allow me to move this out in the front. So I'll have the log of 16 equals, that'd be x plus 2, and then the log of 2. Right? Properties allow me to move that out in the front. And then you would divide by the log of 2. So you would have the log of 16, close parenthesis, divided by the log of 2. This would give you 4. And then to solve, you'd get x equals 2. It's the same thing I did before. Is it harder to do this way than it is the other way? It's excessive? That's a good way to switch. That's excessive. Does it look more impressive, though? It really does. Somebody looking at your paper going, what the heck is that? You know, make you feel real smart. All right. But in other words, I want you to see, guys, that it doesn't matter which way you do it. Mathematicians will say it's faster to just write them as the same base and set your exponents equal. You know, some of you preferred the quadratic formula forever, right? You're like, I'm not factoring. It's faster to use quadratic formula. No, it's not. You could get the same answer, but it was faster to factor. But the other methods still worked. Same idea here. It doesn't matter which way you take this, but you can go do it either way. Okay? So in other words, when you are solving for an exponent, you want to isolate the exponent as much as you can, log of both sides, throw the log out or the exponent out in front, and then you can solve for your variable. Okay? Questions on anything today?